Okay, we're going to do a coffee and cleaners from the shop where I'm here waiting for an inspection. And I'm almost done with my coffee. And in fact, this will be only cleaners adjacent. The Spencer Orgoblo that I recently acquired is a nice complement to this piece of literature, which is from about the same time. And the organ blower was Spencer's original product, almost a decade or thereabouts before they got into vacuum cleaners at all. And this literature covers handling, installing, and adjusting the Orgoblo. All Spencer Orgoblos are guaranteed against defective material or workmanship. Spencer Orgoblos are built to last. Every item in the design and manufacture is chosen on the basis of maximum life of the machine under every condition. And the many, many Orgoblos that are a century old or more and still in service do attest to that. Spencer Orgoblos are all tested at the factory, not only for load, but for noise, vibration, and for assurance of satisfactory service over many years. High-speed machines should be placed farther away from the organ than slow-speed machines, so that any humming or other noise peculiar to high-speed motors will not be audible in the organ proper. The standard Orgoblo of small and medium sizes can usually be placed in the basement beneath the organ. Special slow-speed machines can be furnished for placement inside the organ. Particularly large Orgoblos, handling large volumes of wind at various pressures, should be placed at a considerable distance from the organ in a room especially built for them. Large volumes of air, particularly at high pressures, cannot be handled with absolute silence, and in order to have a noiseless installation, care should be exercised in providing a suitable location for the blower. Place the Orgoblo on the felt pads which are furnished with it, and under no condition bolt it to the floor in any way. All piping should be of ample size. Leaking air pipes consume a surprising amount of power and impair the operating efficiency. Table shows the pipe sizes recommended for the average installation, calculated for various volumes of air, and permit a loss of not over 1/2 inch of water column. Of course, these machines are moving air, or wind as it's known in the organ industry, at a much lower pressure than the vacuum systems. So typically Spencer's vacuums, such as this one, are rated in inches of mercury column, while their organ blowers are rated in inches of water column, more like a residential vacuum system. And to convert between the two, you take inches of mercury, multiply it by 13.59. For 200 CFM, you would use a 6-inch pipe, and I believe my machine's rated for 500, so you'd use like an 8 or a 10. And this goes all the way up to recommending a 24-inch pipe for a 6,000 CFM Orgoblo. Imagine the size of that. And imagine the sound it would make starting up. I don't even think the Orgoblos in like the big Fox Theater organs, etc., I don't think they have 24-inch windpipes. I could be wrong. Electrical, starters, all AC machines should be equipped with a magnetic contactor or a compensator, depending upon the machine size and the installation regulations of the local power company. So a 3-phase AC motor is made to start across the line, but in several of the vintage vacuum system installations that I've been able to check out, some of them were installed with compensators, which is basically an automatic selecting transformer that starts it at a lower voltage, then it steps it to a higher voltage, then it steps it to full voltage. And that's not so much for the motor's sake as for the power, to not let the voltage coming into the whole building sag, because these motors require so much energy to get them moving. Connection to the organ. This is kind of cool because it talks about connecting an Orgoblo to an old organ that I guess didn't previously have a blower, because it's talking about the bellows and connecting to the well using a wooden box if the well is not tall enough to accommodate the pipe size directly. And I like this diagram. This is showing how inflating the bellows will also actuate a butterfly valve, and in that way it'll regulate the amount of air that the blower can push through the pipe. And we have the detail of the soundproof enclosure, looking quite a bit like a walk-in refrigerator. Actually, here you go, refrigerator type door, rubber sleeve padding, felt, sand, ashes, or sawdust, padding. They're really, it's in its own little box. And even in the 60s, they are showing what is no doubt a very old diagram as the detail of the starter with its supply conduit and flexible conduit going to the console switch. But your conduit going down to the blower ends in a conduit fitting, and the wires are in free air going to the motor. By this time, every motor would have had a junction box, or a pecker head as it's called, just like that one. So this is obviously a very old diagram. And we're showing an intake valve on the blower, which some still have and some do not. Mine has an intake valve that's the diameter of the whole blower casing, and I kind of prefer this appearance a little bit. But it has another intake valve on the enclosure. Kind of redundant. I'm sure there was a reason. An air intake of this type permits the air to enter the blower easily and at the same time remains closed or nearly so when the blower is running and using only a slight amount of air. So I guess it's only wind after it leaves the blower. And here's another diagram. Okay, let's look. Now they're showing a blower room reservoir here, which is not shown here. Another method is to build a sound insulating box as shown in figure 2. Okay, so figure 1, they're basically making a room around it. And in figure 2, it's showing a different construction, and this reservoir it's like a big muffler, I guess. And it's still in its own little room. Special notes: if there is an occasion to start the Orgoblo before the wind connection to the organ has been completed, be sure to cover or block out the intake of the machine, otherwise you will overload the motor and possibly injure it. And I touched on that in my video. It doesn't like to run wide open. It can, but it'll grossly overload the motor. And of course, if you do that for too long, it'll burn out the motor, assuming that you don't have a starter connected to it, which has overload heaters in place. Lubrication. We recommend lubrication every 1,500 running hours. And talks about greasing at full operating speed by removing the drain plug and turning the cup. Of course, this would have been before grease zerks were a thing, or were common. I'm sure they were a thing. So you just had the big cup you'd fill with grease, and then you'd turn it, and it would expel the lubricant, the grease, down into the bearing. And talks about how to flush the lubricant and replace it all every 2 or 3 years. Now here's a cutaway. Mine will be basically like this with the 2 impellers and all the different parts that make up the blower. And on the back we have another cutaway and disassembly instructions. 3-stage 2-pressure. So this is your main wind connection, and then you have a smaller wind connection here. This is known as the high pressure outlet. So this one takes air from these 2 stages at lower pressure, and then this third impeller, thinner, draws some of the airstream, compresses it further, and then that's a high pressure outlet for special parts of the organ that will require higher pressure wind. Some big organs, you can look at YouTube videos of the Boardwalk Hall blowers in Atlantic City. You'll see they have 2 giant blowers and then a third small high pressure blower that's dedicated. So you could have a standalone blower if you didn't have a 2-pressure Orgoblo. And I do like this, when quality and service are required, specify Spencer. And you know I love that logo. So anyway, happy organ blowing. And as always, thank you for watching.